In this lesson, we're just going to go over all three types of ionic compounds that we have learned to name and write formulas for. The really important thing about today's lesson is that you need to know when to use a Roman numeral, when do you not use a Roman numeral, when do you drop the ending and add IDE, when do you leave the spelling alone. So I'm going to mix together all three types and make sure that you can tell which rules you need to use in which scenario. All we're going to do today is examples. First one. Barium chloride. I give you the name, you write the formula. So pause the video, try this one on your own. When you're ready, come back and check your work. Alright, barium. If I look up barium on the periodic table, it has a charge of 2+. Chlorine has a charge of -1. Cation comes first, anion comes second, and then think about the ratio needed to make a neutral compound. Barium is +2, chlorine is only -1, so I need 2 chloride ions to cancel out that +2 charge. Number 2. Tin 4 sulfide. The Roman numeral indicates the charge of the cation. So this would be tin 4+. Sulfide is sulfur. Sulfur has a charge of 2-. Cation first, anion second. Tin is +4. That means I need a -4 to cancel that out. Sulfur is only -2, so I would need 2 sulfurs. Next, let's do potassium sulfite. Potassium, group 1 metal, its charge is +1. Sulfite, this is where we need to be really mindful of our spelling. If it ends in IDE, that's sulfur from the periodic table. We drop the ending of sulfur and add IDE. Sulfite with a T is polyatomic. Sulfite is SO3 2-. Cation comes first, anion comes second. Sulfite is 2-, but potassium is only 1+. So I would need 2 potassiums. 2 potassiums, each with a charge of +1, is like a +2. That's going to cancel out that -2. Copper 2 sulfate. So again, be very mindful of your spellings. Sulfide and sulfate only differ by 1 letter. Sulfite and sulfate only differ by 1 letter. Sulfide, sulfite, sulfate. They all sound very similar. So be very mindful with your spelling. Roman numeral indicates the charge. Sulfate with an A is SO4 2-. Cation comes first, anion comes second. +2, -2. Those charges already equal 0, so it's neutral. Let's do 2 more. Let's do ammonium oxide. Ammonium is the only positive polyatomic ion that we really use. It is NH4 1+. Oxide, IDE. That means it's going to be oxygen. If I have oxygen and I drop the ending in at IDE, oxygen becomes oxide. Cation comes first, anion comes second. Think about the ratio needed to make a neutral compound. If this is -2, I need a +2 to cancel that out. So I'm going to need 2 ammoniums. Anytime I need more than one polyatomic ion, it goes in parentheses. Last one for formulas. Let's do calcium hydroxide. Ca is calcium. Calcium is a group 2 metal. Its charge is going to be +2. Hydroxide, OH, 1-. Cation comes first, anion comes second. Calcium is +2, so to make a neutral compound I need -2. Hydroxide is only -1, therefore I need 2 of them. Anytime I need more than one polyatomic ion, I'm going to put it in parentheses. All right, let's go the opposite way. So for all of these first 6 examples, I gave you the name and you wrote the formula. Now I'm going to give you the formula and you're going to have to name it. AlF3. So this is binary, 1, 2 elements. We need to think, does aluminum need a Roman numeral? Well, it's not in the D block. Only elements in the D block need a Roman numeral. The other way you can check to see if it needs a Roman numeral is it on this list? It's in alphabetical order. Aluminum is not on my list, so no Roman numeral. Write the name of the cation. The name of the cation never changes. Cation always comes first. For a binary compound, for the anion, drop the ending and add IDE. Fluorine becomes fluoride. This is aluminum fluoride. This one is ternary, that prefix meaning 3. I have cobalt, nitrogen, oxygen, 3 different elements. We want to look to see, are we going to need a Roman numeral? Cobalt is on my list. Cobalt could be +2 or +3. So I have to write a Roman numeral in parentheses. I'm either going to write cobalt 2 or cobalt 3. In order to know which one I'm going to write, I have to work backwards to figure out the charge. Nitrate has a charge of -1, and there are 3 of them. -1, -2, -3. Ionic compounds are neutral, so my net charge has to be 0. That means cobalt would have to be +3. Charge of the cation goes in parentheses as a Roman numeral. NO3 is nitrate. It is a polyatomic ion. We never change the names of polyatomic ions. We are just going to write nitrate as is. Next example. NH4Br. Again, ternary. I have 1, 2, 3 elements. NH4 is a polyatomic ion. It is ammonium. Find NH4, it is ammonium. Bromine, an element on the periodic table. We are going to drop the ending and add IDE. Bromine becomes bromide. Let's try CaCO3. This one also is ternary. I have calcium, carbon, and oxygen. The name of the cation comes first. Never change the name of the cation. Ca is calcium. Next, think if we need a Roman numeral. Calcium is not on this list. Only elements on this list get a Roman numeral. CO3 is polyatomic. CO3 is carbonate. Never change the name of the polyatomic ion. Calcium carbonate. We'll do 2 more. NiBr2. Name of the cation comes first. Never change the name of the cation. Ni is nickel, so I write nickel. Next, look to see if we need a Roman numeral. Yep, nickel's on my list. Nickel usually has a charge of +2 or +3, so I either need to write nickel 2 or nickel 3. If you don't know the charge of the cation, start with the anion. We can look up bromine on our periodic table. It has a charge of -1. There are 2 bromines. If I have 2 bromines, each with a charge of -1, that's like a -2. Ionic compounds are neutral, so nickel would have to be +2. For bromine, we drop the ending and add IDE. This would be nickel 2 bromide. Last one. Let's do SrCl2. Sr is strontium. Cation always comes first. Never change the name of the cation. Next, look to see if we need a Roman numeral. I'm looking for Sr. Nope, it's not on my sheet. No Roman numeral. Chlorine. We're going to drop the ending and add IDE. Chlorine becomes chloride. This compound would be strontium chloride.